Okay, so we have another lightning talk now on getting started with FPGAs for packet processing.
Okay, thank you for joining this lightning talk. I want to talk with you about some mystery of the hardware acceleration for the data plane. And let me introduce myself. Who am I? My name is Mirek Walukiewicz. I work as the solution architect in the programmable solution group in Intel, and my daily job is to working with the customers and optimizing their workloads, especially in the networking space. It's a short introduction about me. What is a data plane? Yes, some time ago I visited the Computer History Museum in the Mountain View in California, and I found very interesting things, which is the first network card which was designed over the world, and it looks like that you have the cables which connected, and currently we as Intel are making the very similar thing, maybe a bit more complex, which is called the FPGA card with the what we call the Packet Programmable Acceleration Card N3000, which is designed especially for the data plane acceleration. Yes. I want to introduce you and making the very, very short introduction, some 101 session, that how to use this card and how to make a good solution using that kind of the hardware acceleration. Let's start from your problem. I work many, many years as the software designer, yes. My work was to optimizing the software and finding the good solution. Yes, it is the problems in the software could have many sources. Yes. We could think about the hardware acceleration. You could think, for example, okay, encryption is the first one, yes, but it's not only the encryption, yes. You could have different problems, yes. You can have problems with the jumps, you can have a problem with the loops, you can have problems with the PCI access, and first of all, you can have, for example, the problems with the cache using on the CPU, and how to make first step to optimize the software, yes, or to use the hardware, yes. The first step is to find the hotspot. It is and understand how your system works. It is finding the hotspot is very important thing to find a problem what you want to solve using the FPGAs. The FPGA has the limited size, and it can solve, not every problem could be solved. This is example of your problem, yes? So you are the engineer or you are the designer and you want to find some issues or to make sure that your system, which is the very, very complex, is working correctly, yes? Don't try to put everything inside of the hardware, yes? Don't try to put all the problem or the complexity in the hardware, yes? Today it is impossible, and making, for example, the Linux kernel, maybe some guys can explain you that it will be in some future, it will be possible. Because we have new languages for the programming of the FPGAs, yes. Don't believe them, it is impossible to put such complex. What is possible, you can get some part of the hardware and some part of the problem and put this into the hardware, yes. And keep everything around of this problem in the software. What are the tricks here to optimize solution? Yes. The first of all, be careful how the data processing between the hardware and your software application looks like. Yes. In having the hardware, working with the hardware, you have the two hardware components. One is your CPU when your program works, when this main problem is executed. And another hardware component is the FPGA, which you try to find or to accelerate some part of the problem, yes? Let's think about what could be the bottleneck, yes? Let me provide you some example, yes? Some time ago, we tried to accelerate some machine learning function. You know that the machine learning of the deep learning is just you have the small number of the data, and this data passes through enormous set of the tables, yes, which uses the very, very big memory size, and you make the big number of the lookups. You have the big numbers of the change going through these tables, yes? And every step in the machine learning, the number of the tables explodes, yes? So you can have, even in some application, you can have even the 100 tables, your data going through the hundreds of the tables, yes? And designing the FPGA for this model, we provided some simple approach, yes? Okay, we know the most of the operation on the tables is the multiplication, yes? You know that. Okay, multiplication in the hardware must be faster than the multiplication in the software, yes? Because the machine learning is the multiplication, yes? We implemented the very, very good multipliers, yes, in the hardware for the data, and what we saw, software still works faster than the software plus hardware, yes? Why this happens, yes? It happens because the killing factor was the access of the moving the data between the software and the hardware, yes, over the PCI. Our hardware is connecting to the card through the PCI, yes? And imagine that, for example, you have a TensorFlow, and you imagine that you have a packet. And first of all, the software has the packet. Software has the data to be passed, and it must be moved to the hardware accelerator. It changes the location. The data changes the location, yes? And look very carefully how the data is going, yes? For example, the transport of the data between the host and the accelerator could be slower than the moving of this data inside of the CPU using the cache, yes? Additional kind of the problems, yes? For example, in the data plane processing, I am the guy who works mostly with the telco guys, yes? Telco guys are the crazy for the counters, yes, you know, everyone knows the mobile phone, and the most important part of the telco job is to charging you, yes? Counting you, yes, and counting your data, yes? And it is the very, very big problem what they have, yes? And making, for example, the counting problem, of the statistics problem in the software is the terrible job because of the software architecture, yes? To make sure that, for example, you want to make counters, you must create the counters per, for example, your mobile phone, which could be accessed from the many cores from the CPU point of view, yes? It creates many critical sections, yes? So I hope that everyone is the software guy, so maybe I'm not the one who is making the hardware, yes? So. And this critical sections, which means the implementation of the critical sections means that you should implement tons of the atomic operation, which are the terrible for the cache access, and you can lose all your parallelism in the CPU using that kind of massive of the critical section operation, yes? Solving this problem is to, for example, moving some data, some counters which are the most painful, not all counters, yes, but counters which are more painful. We call them sometimes the aggregate counters, which must be handled by the many cores to the hardware, yes, which can solve the problem that the hardware is processing the data parallel, serially, but the software do not have this problem again, and the software can make most of the processing in the parallel way, yes, using the cache very, very efficiently, yes. This is the some kind of the problems, yes. Additional problem, what is to try to put, it is additional trick, what you can do. Try to do not put the part of the problem into the hardware, yes, to the FPGA. Try to solve as much as possible inside of the hardware, yes. For example, going back to our example with the machine learning, we found a very, very good result when we just put some operation of the multiple tables and we were able to put them into the FPGA and making, for example, the most of the processing or all the processing inside of the FPGA, yes. But of course, it requires that not every machine learning algorithm is possible to be put inside of the FPGA. Yes, you must look to the special algorithms which are, let me say, matching the hardware capacity. Yes, normally in the university when you are learning the programming, that the people thinks that, for example, the resources, the memory or the CPU cycles are infinite. Yes. It is just whatever you make, that you make a tables which is the gigabyte, you make a tables which is 10 gigabytes, no problem, yes. In the hardware, it's not the case, yes. In the hardware, you can have maybe 6 mega memory of the very fast memory. You have maybe few gigabytes of the some smaller memory like a DDR, yes. And it is something what is possible to you, yes. It changes your way of the thinking. What else you can do? Yes, additional trick is to make sure that your FPGA on your hardware is invisible to your application. Yes. Here this is example of the segment routing V6 acceleration. I was talking yesterday about more detailed way about what is the problem. I don't want to go into details how it works. But imagine that, for example, the situation, yes, on this left side, you have the not accelerated part, yes. Everything happens inside of the software, yes. And really, this blue part is the part which which creates some router or the switch inside a software switch, and this blue part is visible to the user, yes. In our acceleration solution, we put the hardware acceleration inside of the hardware, but we keep this invisible to the user, yes, or to the application, yes. You see, for example, in the model, the most important part, which is the application, that VM on the top of this, it do not see the FPGA and is not aware that the FPGA is used at all, yes. It is the most important part because you can see, for example, I can make the perfect solution with the FPGA, but a big problem what we have is how to deploy this one, yes, how to make the user using this one, yes. And imagine, for example, that you want to go to the data center, you have the million servers, and you will say, okay, I want to change the millions of the applications, yes, running, because I have created my one smart FPGA application and my application can use the FPGA. It won't work, yes? You must hide your FPGA inside somewhere in the system to make sure that it is invisible and everything a part of the FPGA is not changed, yes? Okay, let me some short and what we can achieve using the FPGA, yes? We are using FPGA for the data plane to get the better performance. What means the better performance? Yes, in the software solution for the data plane using the cores for the packet processing, yes. And we have the cores, and for example, the software solution in some cases can use the 14 cores, yes. It is, for example, the half of the cores using by the server, yes. With our accelerator, we can do this using the 4 cores, yes. It is the 3 times or the 4 times less cores and having the more cores for you for the processing. Yes, it is just the example what you can achieve. And without any change of the application. It is just the solution made by our partner, the HCL, with some our customer who are making the real deployments, yes, and they achieve that result with the customers, yes. Everyone is happy, yes? So we have the better performance and the customer can run the application without any change, yes. Thank you very much. We have the few seconds to the one question. So,
any questions? No? Okay, thank you very much.
okay.